Hello friends, I welcome all of you. In this video, we'll talk about OSI model and we'll discuss its use and importance. First of all, OSI stands for Open System Interconnect. It is designed by ISO, that is the International Standard Organization. So it's a 7-layer architecture, which is a logical model. It's not a device, not a technology. It just helps us understand which application works at which layer, which device works at each of the layers, and how the data is getting moved and processed, where it is getting encapsulated, decapsulated, which header is being added, the purpose of each header, right? So let's understand that. Just take a look at the screen right now. So I have shown you 7 layers in this, and I have also briefly mentioned its use. So let me also add additional information which I have. So this model will come into picture whenever there is communication. So communication happens between client and server. So let's say that you are drafting an email. In this case, you have to choose a website or an application which will help you write an email. Let's say that is gmail.com. You access this using HTTP or HTTPS. So these are the two applications which are needed. Okay, so when client writes an email and sends it to the server, the traffic flow will happen from top to down. That is from application layer to physical layer. So physical layer is actually layer 1, but it is actually shown at the last. Okay, because application layer comes into picture at first stage number 1, even though it is called layer 7. Like you are writing an email, you are creating data. So in any type of communication, you create data or supply payload. Let's say that you are trying to access a switch or a router. So you'll have to choose an application. What are those applications? One is telnet, then there is SSH, there is HTTPS, that is web, then there is SNMP. So these are all applications which are needed for you to communicate, right? For writing an email and sending the email, we need HTTP or HTTPS plus SMTP. So once you work in the industry, in this networking, you will also use the applications like TFTP for uploading the iOS images, right? And FTP for file transfer, transferring the data. So all of these applications work at the application layer, layer 7. So in this layer, we select the application and we create the data. Okay, then what happens in the layer number 6, presentation layer? It's a logical model. Okay, don't worry, it just helps you understand that traffic flow and very much helpful in troubleshooting. So presentation, it notes down the formats. It ensures that whatever design you've used, format you used, the extensions which are there at the email or inside of the email, those are preserved, because the email which you sent, it should be received the same way at the destination. It shouldn't be like the content is overlapped or it is deleted, it is mixed up. It shouldn't be like that. Or if you've attached a song in the format of .mp4 file extension, it should reach the same way. The same song should play once the recipient receives the email, right? So presentation layer takes care of the formats, encryption and decryption. So what are the formats? .mpeg, jpeg, mp4, your fonts, right? Your colors, designs, everything. Like sometimes you bold certain letters, you make certain words italic, underline. All of these are maintained by presentation layer. Then traffic moves to session layer. Like the name says, it creates, maintains and deletes sessions. See, you access Gmail, you are establishing a connection, right? So this layer is responsible for that. Just read. It establishes the connections, it maintains, it ensures that authentication, and it ensures the security of your data. All right. So this OSI model is very useful to get good understanding on what are the things work at every layer and between the client server communication. Okay, so data now has crossed layer 5 and it has gone to layer number 4. So transport the actual transport, just like we travel by car, by flights, right? So we have many options to transport the you can say goods and carriers to move, right? So similarly in this networking we have either TCP or UDP. So these are the two protocols which work at the transport layer. All right, so here the data is not changed in the first 3 layers, it remains same. But when it reaches at the transport layer adds an additional header. It is known as layer 4 header. Let me clear this. So transport layer adds an additional header on the data, and it also divides the data into segments. Remember that. So segments will be used if you are using TCP protocol, and if you are using UDP, in that case it will be datagrams. All right, so TCP or UDP. So these are very important protocols which work in the transport. So TCP has its own advantages, like it does error recovery. It ensures that whatever data you sent, it is received accurately and completely. There will never be any error if you are using TCP based application. So all of those applications which are talked about at the application level, those are associated with either TCP or UDP. If it is Telnet, it will use port number 23 of TCP, right? So every application uses some ports of at the transport layer. All right, HTTP uses 80, HTTPS 443. All of these ports should be known to you. Interviewers ask this question. SMTP 25, TFTP 69 but UDP, right? FTP port number 20 and 21, TCP and UDP both. DNS TCP plus UDP both port numbers 53, right? SSH 22. So remember these ports, these are often asked. MRDP port number 3389, TCP. So all of these applications will either work on TCP or UDP. All right. So it is the actual transport. So here L4 header is added and data is broken into either segments for TCP and for it will be broken into user datagrams if it is using UDP. Okay. My handwriting is a bit poor. I'm writing after a very long time. I'll try to improve. All right. So once it moves to network layer, additional header will be added known as layer 3 header on the top of layer 4 header plus data. So data is actually it is broken into packets. So at this layer it will be either segments or datagram. At this layer it will become packet because network layer deals with the packets. Transport layer deals with the segments or datagrams. So what are the devices work at this network layer? All layer 3 devices. Layer 3 devices means your routers or switches which have layer 3 capability, multi-layer switches like 3750 models. All the routers work at this. So this layer is also responsible for addressing the IP addressing, either IPv4 or IPv6. So it does addressing, routers work here, layer 3 switches work here. What else it does? It does routing, which is the main job. It directs the traffic to the right router or right next hop. So it maintains routing table. This is important. So layer 3 header is attached on this. Okay. And then I told you it becomes packet here. Then it moves to data link layer. Data link layer will add L2 header on the top of L3 plus L4. And the packets here will become frames. Okay, so at this layer addressing also happens, but here addressing is MAC addresses. This layer maintains the MAC addresses. It deals with the frames. It does error detection as well. So it transforms the data into frames, deals with the MAC addresses. All these switches work at this layer. So source and destination MAC addresses information is added, but that information is part of trailer. So this layer also add trailer as well. Let me clear it. So at this layer, one layer 2 header is added on the top of layer 3 header plus layer 4 header. Then the packets are divided into frames. And then a trailer is added, which contains source MAC and destination MAC. Then at the physical layer, the frame, these are divided into bits and pieces, I mean bits and bytes. Okay. So here at this physical layer, your hubs will work. So frames are divided into bits and bytes. It deals with the cabling standards like Cat 4, Cat 5, Cat 6. These are the standards of the cables and all of the mechanisms. And once it leaves the layer 1, then it will become signals because there will be wires. So data, the email which you wrote, now it has become bits and bytes and then signals. And at the other end, when your destination server receives that signals, you can say, then it will convert that into bits and byte at this layer. So at the destination, that the decapsulation will happen. All right. So whatever we did in the at the client side, that will be done at the server end, destination end, but in the reverse order. Okay. So here your bits and bytes will be converted into frames and sent to data link layer, and here it will remove the L2 header, it will remove the trailer. This is known as decapsulation. And then at the network layer, the L3 header is removed, so it will become packets here. So earlier we divided the data into first segments, then packets, then frames, then bits and bytes. Now it is happening, it is taking its shape in the reverse order. So here data link layer, it had frames, those become packets at this network layer. At this layer it will also have the IP addresses, source IP, destination IP. It will be checked by each device. If its own IP is mentioned in the destination IP, that it will accept, otherwise it will reject the packet. Okay, and then the data moves into transport. So data at this at these first 4 layer, it is known as PDU, protocol data unit. Okay, so it moves to the transport layer. Here your L4 header is removed, and it takes it becomes either segments or datagrams. All right, and after that, in the first these 3 layers, there is no encapsulation or decapsulation happen. Okay, so the recipient will receive the email the way it was written. This is how the client server communication happens. So it is just for making you understand how things are taking place. There is no physical device or any technology associated with this. It is just to make you understand, and roles and responsibility of each device and application is defined here. All right, so it is very easy, just understand. And many questions are asked in the interviews, like switch works at which layer? Answer will be data link layer, but it also works in the network layer, that is layer 3, but only when it has the layer 3 capability. Okay, routers work at layer 3, hubs work at layer 1. All right, and your FTP application, where does it work? Application layer. Okay, so all the applications will work here, and the role of presentation layer, role of session layer. So I try to explain you with whatever knowledge I have. I hope it's been informative to you. Thank you so much for your time.